Hi everyone, welcome to Singapore Geospatial Week Plus 2020, an event organized by GeoWorks, Singapore's Land Authority Geospatial Industry Centre. Today is our last day of Singapore Geospatial Week, and we're excited to have Prof. Kotaro from SMU to share on the topic, Characterizing the Physical World Accessibility at Scale. If you have any questions during the webinar later, please leave them in the Q&A chat box and we will answer them at the end of the webinar. Thank you, and without further ado, I will now pass the presentation to Professor Kotaro.
Okay, thank you so much for that introduction. Let me first share my screen, or am I already sharing the screen? Share the screen. Okay. Okay, let's start. So thank you very much for people from GeoWorks for inviting me, and thank you for 20 plus people for attending this talk. So let's start without further ado. So today I'm going to talk about how we can combine Google Street View, crowdsourcing, and images such as satellite images, and also some automation to collect a lot of accessibility information. But before I start, let me just introduce a little bit about myself. So I'm Kotaro. I'm Kotaro Hara. I'm originally from Japan, Osaka. I was studying Osaka University, and then I moved to Maryland, went to Carnegie Mellon, and now I'm here in Singapore. And I'm an assistant professor and LKC fellow at Information School of Information Systems School at Singapore Management University. So yeah, let's start. So today's topic is a lot about accessibility, and I'm not sure if everyone knows about accessibility. So let me just provide a definition so that you get so we are on the same page. So when we say accessibility, it can mean, to design that, accessibility to design that enables people with disabilities to interact with buildings, products, and services, and other things. And because I'm a computer scientist, when I say accessibility, when I'm talking about accessibility of software systems or information for people with disabilities. And so accessibility or disabilities is very diverse. For my research, I have worked with people with motor impairments, mobility impairments, or visual impairments or developmental disabilities. But today's talk is mostly about accessibility for people with mobility impairments. Okay, let's start. But just to give you a context, so worldwide, there are about 65 million people who need wheelchair as mobility aids. And only within Singapore alone, there are about 100,000 people who have some kind of disabilities. And the mobility and independence of this population, it can be affected by things like missing curb ramps, obstacles, surface problems, and just no sidewalks. So they cannot traverse the city freely. So obviously this is an infrastructural problem, but it is also a data problem because people don't know which areas, for example, in Singapore, they can travel to if they're on wheelchair. So to address this kind of problem in my research group, we're trying to make technologies like this. So, for example, information visualization that shows which area of the city is accessible for them. So if they click some part of the map, it shows, oh, okay, this area is not so accessible. So when you're traveling, you want to be careful. Or we want to make technologies like accessibility aware navigation systems. So it's like a Google Maps navigation, but it is also accessibility aware. But if you think about this, you need a lot of data about geographical information of accessibility of sidewalks. So that's what we are trying to collect through the research project that we are working on. So our goal, our overarching goal is to really transform the way we collect street level accessibility and also use that data to create new GIS systems like navigation systems and so on. So let me step back a little bit and explain how this kind of accessibility data has been collected in a traditional way. So traditionally, this kind of accessibility data, the government organizations or volunteer organizations, they go out in the field and use this kind of a accessibility assessment form to collect data about sidewalk accessibility. But although this is great, it can collect a lot of high quality data. It's really time consuming, expensive because it requires on-site audit. Recently, there are applications that allow citizens to participate in this kind of data collection on site, like SeeClickFix or New York City 301. It allows people to report things like, oh, okay, some sidewalks are broken, which is an important accessibility feature of the street. But again, this requires people to be on site, so it's not very scalable, and the data is limited to where people go. Similarly, there are some web applications like Wheel Maps or Access Map. Again, they require people to be on site, and the data is limited to where people have visited before. So our research approach is to remotely collect street level accessibility information from Google Street View using technologies called crowdsourcing and some kind of computation. So today I want to talk about, okay, is it really possible to collect accessibility information that I'm talking about from Google Street View? And if I can we use technologies like crowdsourcing and computer vision to scalably collect the data? And in more detail, so let's start talking about the first point. And to show the feasibility of using Google Street View to collect data, I want to ask two sub-questions. The first one is, are accessibility problems even visible in Google Street View? And also, does this accessibility data have value for people with mobility impairments? So yeah, to answer the first question, I just want to show you a video. So this is pictures of Washington, D.C., where I used to live. You can see that some sidewalks at the intersection, there are no curb ramps, or some sidewalks they have so much vegetation, some obstacles, so it's not passable. So obviously, these accessibility problems, it's visible in Google Street View. So that's great, but then you might be asking, okay, it's great, but is this kind of information actually useful for people with mobility impairments, like wheelchair users or people who use scooters? So to answer that question, as a researcher, I interviewed 20 people with some kind of mobility impairments, like people who use wheelchairs. We asked a lot of things, but importantly, we asked, how do they plan to trip and assess the accessibility of the destination that they haven't been to? And important thing that we found out is 11 out of 20 people I interviewed, they already use street level imageries like Google Street View and also satellite images to assess the built environment's accessibility. So this is important so that it's already used, it's very useful. It's just that the accessibility information is not readily searchable because it's not indexed in a database. So, okay, now we know this kind of data is useful. What we want to do is we want to extract this kind of accessibility information from pictorial information like Google Street View or satellite images so that we can organize it and then deliver it to people through some software API or some kind of applications that I talked about earlier. So, okay, I want to collect this kind of accessibility data. How can we do it? One obvious approach that I took first was using crowdsourcing. And if we ask a question like this, what accessibility problem exists in this image? You might be able to answer. Okay, actually, I think it's clear, but there are two poles blocking the path. And also there's a missing curb ramp at the end of the crosswalk, right? So just by seeing this picture, you can answer this question. So that's what we did. So crowdsourcing, what it means is we ask a lot of people over the internet to answer this kind of question. So we create a custom-made user interface, and we ask them to mark all types of accessibility problems using this interface to people over the internet. We recruited a bunch of people from this service called Amazon Mechanical Turk. We can pay some amount of money, and then we can ask them to do online work. So the research here was, okay, can these people recruited from Amazon Mechanical Turk, can they provide accurate information? I'm going to skip the details of the study, but answer was yes. They could collect 87% the data with 87% accuracy. So it's not perfect, it's not 100%, but it's pretty good. I want to show you examples of what kind of data we collected. So those people we hired, they could label missing curb ramps, again, missing curb ramps, but sometimes people mislabeled objects like this stop sign in the sidewalk. So even though this object in the sidewalk, it's not really blocking the paved area of the sidewalk, we marked it as incorrect. So that's why the accuracy couldn't really reach the 100%. Okay, now you might be asking, okay, that's good. The crowd workers, they can collect data with 87% or something, but is this data that we collected, does it really reflect the perception of people with motor impairments? So that's what we study in the next study. So we recruited wheelchair users, and we asked them to perform the same task, and then we checked whether their opinion matches with our opinion toward what constitutes accessibility. So here's an example of recording from the study session.
Okay, definitely this utility pole is an object in path. Okay, object in path. I'd say that's a 5.
So this participant had a limited dexterity, so actually research assistant, she helped him label the accessibility problems in the sidewalks. But okay, again, I'm gonna skip the details of the study, but overall, we found strong agreement between wheelchair users' view toward what constitute accessibility problems and our view toward accessibility problems. So this is good because that means if we can find the accessibility problems from Google Street View, that means that data that we collected is actually useful for people who have mobility impairments. So learning from this insights, we actually polished the user interface to collect this kind of data. You can actually visit projectsidewalk.io, and we actually deployed it. So anyone can contribute to data collection. We deployed it to the city of Washington, D.C. because that's where I used to live. The system was deployed from 2016 to 2018. And we collected data from the entire city. So we asked people to virtually walk around every street of the Washington, D.C. And they marked all the sidewalks, accessibility problems. Okay, so that was great. So we showed that we can collect accurate accessibility information using crowdsourcing, and we actually deployed it. And we showed that, you know, if we are only talking about 1 or 2 cities like Washington, D.C. or Singapore, we can probably collect sidewalk accessibility problems quite easily. But we try to be ambitious. If we want to collect every single street's accessibility problems around the world, not only Singapore or Washington, D.C., but all the cities in Asia or US, how can we make the method more scalable so that we can collect data from everywhere, right? To do that, crowdsourcing is a little bit too expensive because we have to pay a little money to people. So we want to employ a little bit of automation, like computer vision technique. So that is the next topic. And I only have 5 minutes, so I'll be really quick. But for this part of the research, we focused on collecting the curb ramp information. because curb ramp, it's really important feature for wheelchair users. Without curb ramp, people with ambulatory disabilities, they cannot navigate the city. And we also thought it's easier thing to find in a picture because they're visually salient. We found out it's not really true, but at least that's what we thought in the beginning. And we use this kind of technology called object detection algorithm. So if you go to Facebook, if you look at a picture, they did a face detection, right? So instead of detecting the faces in the picture, we wanted to find curb ramps in the sidewalk images. We use this algorithm called deformable part model. And here's an output. So if you apply this kind of object detection algorithm to this kind of street view picture, this is the result we get. So these red boxes represents the predictions. So what computer thinks are the curb ramps. Obviously, they're not very accurate. Like curb ramps, they shouldn't be on the sky, in the sky, or on top of the roofs. So obviously, there are a lot of mistakes. So we further did post-processing. We used 3D point cloud data to filter out some nonsensical data, the results, and we refined the result. And we had another step of refining the data, and we cleaned up the data. And so the computer could detect curb ramps, but we found out that they also make a lot of mistakes. So that was not perfect. And just to show you the result quickly, in research, when we are assessing the accuracy of computer vision algorithm, we use these metrics like precision and recall. Our goal is to plot this precision recall results on this two-dimensional chart. And we want to push this curve to the top right corner so it represents, it shows that the computer algorithm is doing a good job. When we actually draw this curve for our algorithm, the result was not that great. So even though we want the curve to approach to the top right corner, that wasn't the case. And actually more than 20% of the curve ramp data was missed by computer. And if you compare it to the people's, when we ask people, we can get the accuracy of around 80%. So that was kind of similar to the result from the first study. So this shows that computer vision alone is not sufficient to accurately find the curb ramps. And we suffered a lot of problems like these, like occlusions. So sometimes pedestrians are walking in front of the path, in front of the curb ramp. So computer vision gets confused. Also shadows, they also confuse the object detection algorithms. Scale, some curb ramps that are far away, they tend to be small. Depending on the perspective, curb ramps look different. And sometimes structures like driveways, it confuse the algorithm as well. And depending on the areas of cities or between cities, the design changed, so that was hard. So we tried to combine automated algorithm with manual labeling of curb ramps. So we created the user interface to collect curb ramps. And also we created another interface which allow people to verify computer vision algorithms so that we can ask people to delete the wrong detection results. So again, I don't have much time left, so I'm just gonna skip all the details of the study. But when we combine manual effort and computation, we can achieve the result that's comparable to when we are asking people. And at the same time, we could reduce the data collection cost by 13%. So 13%, it's not that great. I mean, it's not 100%, right? But still, if you keep working on improving the computer vision algorithms, we expect this number to increase to 50%, 60%, and so on, so that we believe the data collection efficiency will go up. Just to wrap up, I want to talk about something that we are working on right now. So, okay, one of our goals is to make this process of data collection more efficient. So we were thinking, okay, can we do a little bit more smart approach to where we focus on data collection? Some areas it should be more accessible, and some areas they tend to have a lot of accessibility problems. So can we focus our efforts to collect data from inaccessible areas, for example? And then, of course, another thing that we want to do is, okay, now we have this kind of data collection methods. Can we make use of the data that we collect to make accessibility aware GIS, geographical information systems? And also, we focused on collecting data for people with mobility impairments, but similar approach can be used to collect data for bus stop accessibility, data about urban vegetations, like something about public health, like cleanliness, and also some data that's useful for urban planning. So we are trying to work on these projects, and some projects are actually ongoing. Okay, so that's it, and I've overshot a little bit, but this project, I originally started when I was a student in University of Maryland, and I collaborated with a lot of people, including my advisor, John Frolick. And yeah, so that's it. And by the way, this is a kind of a shameless advertisement. I'm always looking for PhD students and engineers. So if you're interested in this kind of research topic, please let me know, and maybe we can work together. And that's it. So thank you. I think I'm gonna move on to Q&A session.
Hi, Prof. Kotaro. Thank you so much for your presentation.
Yeah.
So I think now we have some time for Q&A. If the attendees have any questions, please feel free to leave them in the Q&A chat box. And I think we have one question from the audience. So the question is something being deployed in Singapore with what you have presented?
Okay, so it's not really deployed. So for example, we created the actual system, sidewalk, project sidewalk.io, and it's deployed in some parts of the US and South America, but that one is not deployed in Singapore. I have been testing some technologies for Singapore context, using some imagery to collect accessibility information, but it's not publicly deployed yet.
I see. And perhaps a question of my own is that in Singapore, right, because we have so many different kinds of pedestrian sidewalk, you mentioned that you have to do different kind of design and mapping. So roughly how long does your system take to like learn the different kind of sidewalks for cities such as Singapore?
I see, that's a great question. We haven't tested yet, but this kind of computer vision algorithm, it's always improving. And recently there's like research in using very little amount of data to adapt to new contexts. So maybe we can employ those kind of techniques to, make the process of adapting faster, but we haven't tested, so I don't have a good answer to that.
It's okay, thank you. And we have a question from Edward is, what is the status of barrier-free access project at SMU?
Okay, so yeah, actually at SMU, a lot of people are working on accessibility, and some people actually building the applications like accessibility aware navigation system. I think those are the project that Edward is talking about. They are, I think they have been prototyping, and then they have a system that's running. I don't know if they are publicly available yet.
And we have a question, besides detection of ramps, can we detect other barriers? For example, inclinations, width of the paths. Does it help to geo-reference the object at the same time?
Okay, that's a very nice question. So to answer the second question, I think if you have that kind of information, it will definitely help people. It's going to be useful information for developers or actually end users. Can we detect other barriers? So I think so. So for example, inclinations, maybe we can use not imagery, but other data like, we have we can collect altitude information. Maybe we can infer the inclination from there. With this, I think we need to think a little bit about it because we need a 3D data, and we know from like 2D pictures alone, it's a little bit hard to assess whether the sidewalk is passable, even you have some obstacles. Like so the notion of obstacle is a little bit hard to say. Even you have some object in the past, if you have, for example, 1 meters of the width in the sidewalk, wheelchair users can still pass. So we need more fine-grained data about the sidewalk, a bit more fine-grained than the static images to detect the width and then assess the passability of the sidewalks. So, and I haven't looked into it yet.
I see. Thank you. Are there any more questions from the audience that they would like to ask Prof Kotaro? So if there are no other questions, then I'd like to thank Prof Kotaro for sharing with us. Oh, we have one more question. What's your opinion of point clouds to detect these objects?
I think it's really interesting research topic. I think it's kind of 3D computer vision is actually a quite cutting edge topic by itself, and using that data to assess the accessibility of the city, I think it's really interesting. And if we do it right, it can be really useful. For example, what I said, like assessing the width of sidewalk and then assessing the, passability for different types of wheelchairs, for example. So I think it's really exciting.
I think we all look forward to the day where we can actually really help those people with disability. Like you mentioned, in Singapore, we have about 100,000. So that's quite a large number.
Mm.
So I think if there's no other questions, then, there's a comment from Edward Lim. Just a comment, parents with strollers or prams or delivery riders using bicycles or e-scooters have a lot of knowledge of barrier-free access.
True. That is true. Yeah, so maybe we can ask those people to contribute to some data as well. That's a great point.
Thank you, Edward, for your comment. So on behalf of the attendees, thank you so much, Prof Kotaro, for sharing with us all your projects and useful findings. So right now we would like to ask the audience to kind of tune into our other webinars that we have lined up for the rest of the afternoon. So we also have a webinar by TomTom as well as AWS this evening. We will be pasting the webinar links in the chat box later. So thank you so much all for joining us today, and we hope to see you again soon. Thank you, everyone.
Thank you very much for coming.
Thank you. Bye-bye.